Let's look at part 2 of the homework. If I can find it. What? Okay.
Hey.
Howdy.
Hey. We're just looking at part 2 of the homework.
Okay.
Okay. I'm so sorry, you guys, but I have like a ton of family here, so I'm going to try and go through this quickly, and so just stop me if you need help.
Yeah, that's fine.
Is it okay? Did you guys do part 2 or did you wait? I know it said to wait.
I waited because it said to.
Okay, all right, that's fine. We'll kind of go through it together then. Okay, so number 1, if you read the problem here, a professor is trying to figure out whether or not there's a difference between BYU Idaho male students and female students as far as wages go. Right? So we designed the study. That's the question we're asking. Is there a difference between the mean wages of male BYU Idaho students and female BYU Idaho students? So the null hypothesis is going to be that the average wages are the same, and the alternative hypothesis is going to be that the average wages are different. Does that make sense?
Yeah.
Okay. All right, in collecting the data, what the professor did was he just asked his classes what their hourly wages were. So he found, in number 3, describe the data. He found that the males on average had 11.935 for their average hourly wages. Females had 9.759. Standard deviation for males, though, was a lot higher, 10.49, and for females was 3.169. And then his N was 88 and 95. I mean, it's pretty easy for us to look at those and see it, but for some reason mine calculated 85 and like 91, but whatever.
Yeah, mine too.
Did yours do something different too?
I got 85 and 91.
Yeah, so yeah, I don't understand why that would be different, but that's fine. Okay, so making inferences. This is an independent sample hypothesis test because group 1 does not determine group 2. They're independent groups.
Yeah.
Okay, all right. And then B, are the requirements met? It was not a simple random sample. He just sampled his classes, so that was really more of a convenient sample. But it said because N is large, we can assume normality, so I guess they're just moving forward with the test. I mean, for me, I would feel like it's not really necessarily a good indicator, but
Yeah.
the test statistics, because of the order of the information I put in, it was negative 1.836 because I put females first and males second, but it will just depend on what you put first and second columns. Degrees of freedom, 98.263. It all comes up on your 2 test sample means.
Yeah.
So, I mean, I'm just reading this off of what the chart told me. P-value 0.069. They gave us a confidence, or not a confidence. What is that? What is alpha called statistically?
The
Value? Like what? Oh, I see what you mean.
The 0.05, what is that called?
alpha level, maybe.
What is that?
Confidence?
Alpha level.
No, it's not the confidence level. That would be 90.95.
Okay.
0.95 confidence level.
Let me see.
It's in my notes somewhere. I'm not going to worry about it right now. Okay, so because p-value is high, we fail to reject the null hypothesis. So we don't have sufficient evidence to say that there is a difference between wages of male and female BYU Idaho students. Confidence level, they have negative 0.17622, 4.52858. That's because they put males first and females second. If you put females first, you would have gotten negative 4.52858 and then positive 0.17622. Because 0 is included in that confidence interval, you know that we have to fail to reject the null hypothesis. If 0 is included, we have to. fail to reject the null hypothesis. So then it said take action. I don't know what you guys said for your action. I jokingly said we keep taking data until we get the information we want. Because we want to see that males really do earn more money. I'm just kidding. All right. It looked like it to me, honestly. Okay. All right, so that's our homework. Do we want to open up the quiz now? Any questions?
No.
No? Okay. Let's open up the quiz and go through that. So we're looking at number 3. What requirements must be checked when conducting a hypothesis test comparing 2 means and independent samples? We need a simple random sample drawn from the population, and we need X bar to be normally distributed. So I put
So
A
A
and
and
B.
A and
Yeah.
B.
Okay.
Yeah. Number 4, the test statistic for a hypothesis test comparing 2 means with independent samples is a T-score, right? Can't be a
Yeah.
Z-score. Number 5, 2 samples are independent if knowing which subjects are in group 1 tells you nothing about which subjects will be in group 2.
Correct.
Okay. And now I'm looking at dentist office bills, so you got to open that up.
Okay, let me
Yeah, and we've got to put the information in to...
just like bookmark this page that has all the links on it.
Yeah, well, you know what? If you open up any of your lesson pages, Annie,
Yeah.
it's also at the top. It has a little icon that says data files on the left-hand side, so you can open
Oh,
it.
there we go. Okay.
Tell us about that too, so that's kind of nice. Okay, let's.
Okay. Let me grab this file open here.
Come on.
Here we go. All right, so we're gonna erase this stuff.
Oh, that's fine.
Okay.
I got 19.000.
You're ahead of me.
Copy.
Hannah. I'm excited.
Okay, hold on. I'm almost there, Bernice.
Yeah.
Okay. So you said, all right, what are we trying to find? What do they want us to find?
Let's look up
The
this movie.
degrees of freedom.
Okay, let's see.
Isn't
What-
degrees of freedom just N-1?
It is, but this is trickier because we've got 2 variables, Annie.
Let's not.
So
Okay.
I'm not exactly sure how they're calculating it. It didn't say in the lesson that I saw. Did anybody see that?
Yeah, I couldn't find it either.
Yeah, so I'm going to assume that this is right because it was decimals in our answers. That's what we had.
Okay.
All right, so it says round to 3 decimal places. Did you have 37.996?
I do.
Yeah.
Okay, 37.996 then. What is the sample standard deviation for Rexburg? Rexburg was the second set of information, if you plugged it in the way it read. So they said standard deviation is what we're looking at?
Mm-hmm.
Okay, so 206.637?
Yes.
Okay.
This-
What is the test statistic? I have negative 0.434.
Yep, that's what I got.
Okay.
Value.
What you got?
Negative 0.434. What is the p-value? I have like 0.665.
Yeah, so I put .667.
Right, okay. Yeah, that's what it's going to have to be.
Isn't it less than, not greater than? For the test
Well, not
type?
with the p-value, right?
Well,
um,
it affects it though. If it's less than or it's greater than for the test type of test. Isn't it less than for the type?
Oh, I'm sorry. I don't. What is the correct decision based on the substance? Oh, as far as the type goes, oh, did we mess that up? Let's see.
Fine.
Oh, yeah.
I changed mine to less than.
Okay, hold on. Yeah, you're right. Yeah.
Mm.
With the level
Okay.
of significance, we didn't even put in the level of significance. We're going to want to change all that. So the level of significance we want to change, guys, to 0.90.
Well,
And
everything
we
else
want to go to less than, just like you were saying, Drew. Thank you for catching us on that.
didn't mean to throw you off there. Well, I had 0.9 in and less than, and I got all the other answers the same up to the p-value for you.
Oh, you did. Okay, let's see.
That's
Okay,
why
so what do you guys say? Sorry, I was.
Okay, so everything stayed the same except p-value, Bernice, because we need to change the confidence level to 0.9, and the type of test is a less than test.
yes.
Okay, so now I've got 0.333.
There you go.
Yes, 0.333, because it's a one-tailed test, so it's going to be half of.
Yeah,
Yeah.
point.
Right, okay. What is the correct decision based on this evidence? P is too high, right?
They'll fail.
So we fail to reject the null hypothesis.
Fail. All right, and then
Yeah,
we
fail
try.
to reject the null hypothesis.
And then we try it with not equal to.
Hypothesis is not what is the correct decision based on this evidence. We still would fail to reject the null hypothesis, right? I mean, P would be even higher.
Yeah.
Unless
Yeah.
it's greater than, yeah.
Okay. All right, so we're going to go to freshman dinner.
Ooh, let's look that up.
Woohoo!
Freshman dinner. Utah and Colorado.
Okay.
Would it be not equal to?
Gosh, I haven't even looked yet. I'm sorry, Annie. I'm just
No,
getting
you're
the
fine.
information plugged in right now. Okay, so let's see. Set a file freshman to answer questions freshmen. The data represents the number of times freshman students from Utah and Colorado cook their own dinner in a month. You suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. The null hypothesis, mu equals, use this number. Yeah, it would be not equal to, right?
Yeah. Okay.
What is the test statistic? So let's change everything here. Our confidence interval is now 0.95, and it's not equal to, so we need to change all that.
So 0.845.
0.845 is what I've got too.
You got 0.411.
You did not get that, Drew?
Oh, I did. I was just under the p-value.
Oh, okay. Sorry. I was like, wait, what? Yes, 0.410.
411.
Oh, does it go up? Sorry.
Got a 7 after 0.
411. Okay. Yes. Yes, I've got that too. Okay. What decision do you make? P-value is too high.
Yeah.
Lower limit. Negative 1.5.
Okay, and I got the lower limit as negative 2.214.
Oh,
So are you guys there?
yeah.
Sorry, that I don't know what happened there. Some kind of glitch in Google Hangouts. Okay, so are you guys reading what I'm reading? Are they wanting us to go back to the last one that we did?
use information from question 12.
Huh?
That's the same question.
That's the same data.
Same thing.
It's the same data, you think?
Yeah. This from question 12.
Now use the information and data just above question 12. Okay, to get
Oh.
check to 95%. Well, isn't 95% confidence interval what we were doing anyway?
Yeah.
All right.
Yeah, it's weird how they word it.
Yeah, it really is. Okay. Hmm.
So I got negative 2.214,
That's what I've got.
Do that.
and then 5.147.
Okay.
So if you're gonna go, you're gonna have classes together. Only the girls.
Okay, so negative 2.214 and 5.147.
Uh-huh.
Okay. Are we ready to submit? Do you want to go over it again?
And I look forward to your letters.
Oh, yeah.
Bye.
I got
What do you
100%.
Oh, well, I guess.
Oh my gosh, I thought you were talking to me.
Okay. Yep. Me too. Yay!
That one was fairly simple.
Yeah, I thought so too. It was so similar to last time's, huh?
Uh-huh.
Yeah. So, yay. All right. I'll see you guys on Thursday.
Sounds great.
Bye. I'm sorry. Is everybody okay? Are we good? I'm sorry. I know that was fast. Okay. Thank you guys. I'll see you Thursday.
Okay, bye.
Bye-bye.